Good morning, good afternoon, everyone. Welcome to the Wirepas Massive 5.1 launch webinar. We are just opening the webinar, waiting for all attendees to be connected, and then we will start in a few minutes. Thank you. Good morning, good afternoon. Welcome to the Wirepas Massive 5.1 webinar. We are just waiting for 1 more minute for the attendees to join, and then we will start. All right, thank you for your patience, and warm welcome to the Wirepas Massive 5.1 launch webinar. So during this webinar, we will give you more information about the Wirepas Massive 5.1, the content of the release, the new feature, and also the migration path if you are already using another version of Wirepas Massive. Sorry. Let's move to the agenda. All right, so I'm Sebastian. I'm running customer success at Wirepas. I will run the webinar today together with the fantastic team from Wirepas with me during the meeting today. We have Ville Juven, Gwendal Rahul, Antti Rouponen, Kari Pil together with me, and we will present different section as presented here. So first of all, I will go through a quick introduction about the release. What are the key features, and also what is the compatibility matrix for you to know the dependencies behind this new release. Then we will go through the key new feature. So Ville will talk about the heterogeneous network. Gwendal will talk about the new OTAP. Then Ville again will talk about the radio installation quality. Gwendal again will talk about the MQTT library. And finally, Antti will talk about the other features and updates related to this release. Then Kari will talk about the migration path, so how to migrate to this new release. And then I will talk about the practicalities, followed by the Q&A session. So feel free to ask your question inside the chat window. we try to allocate as much time as possible to answer your question. If we are not able to answer all of them, we will come back to you either via the ticketing system or via email with the answer. A small comment, you may have noticed that Wirepas Mesh is now Wirepas Massive, and I really recommend you, if you have not yet looked at our new brand, to visit wirepas.com to learn more about that. This being said, let's move to the key topic. So let's go through the Wirepas Massive 5.1 release presentation. A couple of words on this new release. So we have developed this new version of Wirepas Massive with, I would say, 3 main objectives. The first one is to improve the developer experience. We have now full online and beta documentation, and we are now also introducing new tools to help developers like MQTT library that will be presented later on during this webinar. The Wirepas Massive 5.1 is also about better interoperability and richer SoCs. So this release allows to mix SoCs from multiple vendors with different TX power. So you can, as you wish, select the best, I would say, chipset for your use case and mix different chipset with different characteristics. We also enhance the support of chipset with 2 new products coming from Silicon Labs. So the Gen 2 SoCs, namely the XG21 and XG22. We'll come back to that a bit later. And we also support devices without the 32 kHz crystal in order to, I would say, ease the portability of Wirepas Massive onto existing hardware, existing products. Of course, we are also making enhancement and new features. We have slightly improved the over-the-air programming mechanism to make it more easier and more reliable. We have enhanced the advertiser role for ultra low power nodes. Very useful, we will see after, for asset tracking and also potentially for lighting. And we are introducing the radio installation quality for easy installation quality indicator to get an information about, well, how good is the network when we install. And last but not least, this release is backward compatible with the Wirepas Massive 5.0, which you may be using already today. We are also restructuring our tools. You may have noticed that we have introduced last year the Wirepas Developer Portal. We are making a new step together with the new branding. And really, the developer portal becomes the entry point for you developers toward the Wirepas technical community. Of course, we are still using GitHub for all our open source components and ShareFile for the binaries of the product and some user-specific files. This is something you might be already used to. So this is the new developer portal where you have updates, news, and also the different documentation with a real focus that we are putting now to provide more how-to and user guide in order to really describe how to make different tasks, I would say, with Wirepas Mesh. Let's look a bit about the feature benefits of Wirepas Massive 5.1 for the different application. So for all application, clearly the 2, I would say, main features are this OTAP v2, which makes the OTAP really easier and faster to deploy. And also this heterogeneous radio support, including front-end module support for better interoperability and fit-for-purpose system on chips. So those are really the key ingredients, I would say, valuable for all application. We are also introducing this MQTT library tool to ease the development and integration. If we look more toward the smart lighting, we can highlight this advertiser role, which enable ultra-low power switches to be installed. So that slightly reduce the power consumption of a switch running the normal, I would say, non-router modes of Wirepas Massive. This 32 kilohertz crystal removal is allow a much better interoperability, for example, with existing LED drivers, which most of the time don't have a 32 kilohertz crystal on board. And the Scilab G21 is also a fairly good chipset for lighting application. If we look at the smart tracking, and there will be more coming on the smart tracking later on, but the two key elements we can highlight is the advertiser role for mass inventory and the support of Scilab G22 for ultra low cost asset tracking tags. That's quite an interesting solution as well. Of course, this release is not coming alone as a stack release. We have a couple of other components which are released together with the stack itself. So of course, we have the Wirepas Mesh SDK version 1.2.0, which is available from GitHub, very similar to the one available today for the Wirepas Massive v5.0. We have introduced a minor folder restructuring to ease the navigation. We have introduced a reference application for a control node, which demonstrates this advertiser role. And we are also introducing an application persistent storage so that the application can store persistent data. Wirepas Gateway Driver 1.4.0, mainly linked to the support of OTAP v2, but also a bit better packaging, especially for the Docker images. The Wirepas Network Tool, version 4.0. So a side note on that, the WNT4 will be introduced in the 4th of June, so next week. And this new WNT will mainly covers the support of the 5.1, including the support of the new OTAP, some improvement on the user interface, as well as some performance improvement. A new component, the Wirepas MQTT library, which is a Python wheel with the objective to ease the network interaction from the backend. So it's a kind of replacement of the backend client that you may have seen or used before. And finally, the share file and the documentation structure, where all the documentation are now fully online on the developer portal. And the side comment is that we're going to remove the password for the stack release, also to ease the access for the stack. If you have a ShareFile account, you will be able to access the stack right away. Of course, we have many components, and I need to talk a bit about the compatibility between them. So let's spend 1 minute on that. So we have here, and this compatibility matrix will be, of course, in the release note. But we have this Wirepas Massive version 5.1, which will be released later today. This is compatible with Wirepas Massive v5. Of course, when using the feature set of the Wirepas v5, so you need to ensure that you stay at 5.0 features perimeters. You need to update the SDK to version 1.2.0. you need to update the VNT to version 4. So we don't have the backward compatibility of the v5.1 toward backend with version 3, but the backend version 4, of course, is compatible with the previous version. We will introduce later on the Wirepas positioning engine version 1.4, which has a dependency toward the VNT4. So there is also a need to update VPE. And finally, the Linux gateway, where we introduce this 1.4 for support of the new OTAP. You can still use the 1.3, but without the OTAP v2. And because there is no API, strong API change, we highly recommend you to update as well. I won't spend more time on this compatibility matrix, but yeah, please pay attention to that from the release note when you start with the Wirepas Massive 5.1. And again, to be very explicit here, the heterogeneous network is not supported if you do a mixed network between 5.0 and 5.1. This is especially because the 5.0 is not able to understand those new mechanisms that we have implemented in the 5.1. Okay, so if you want to use the heterogeneous network, you need to update all your network to 5.1. That's all for my part. Let's move to the key new feature introduction. I will now pass the mic to Ville, who will talk more about this heterogeneous network and front-end module support. Thank you.
Okay, thanks, Seb. So, hi everyone, I'm Ville, and as Seb mentioned, I'm here to talk about the new feature called heterogeneous network support. And we'll start with a nice introduction page stating the problem that the historical limitation with Wirepas has been that you cannot mix different type of radios together. And if you move to the next slide, I'm going to tell you a bit how we have solved this problem. So a short list of what we are going to go through, short introduction, then Seb already covered the compatibility, but repetition is never wrong, so let's go through that again. Then we go a bit through about what the development results were and how we tested this. And finally, the relevant API changes. So Wirepas. The Wirepas nodes are basically built on any hardware and any chipset by many vendors, and these chipsets have different radio timings and radio propagation parameters, mostly DX powers and RX sensitivity. And the target of this new feature is to support seamless operation between the nodes with different kinds of hardware and obviously working on the same radio frequency band. And the design actually covers the following aspects, which is the differences in DX powers and RX sensitivity, a new option to add a front-end module with DX and RX gain, radio link level compatibility between different clock and timing implementations, as well as link level compatibility regardless of the system on chip dependent radio timings, which are in this case are the baseband or RF state transition delays. And about compatibility, it might be implicit, but just to make sure, the compatibility in this case means that nodes running 5.0 and 5.1 will understand each other's radio packets, but for full network and link level compatibility, this only applies to networks that are homogeneous. And mixing heterogeneous nodes will require the network to be updated to 5.1, the full network. And yeah, so the result is obviously that you can now mix different types of nodes into the same network. And for testing this, we created a 600 node network to the Wirepas office, and the result is that it obviously works. The performance in this network is comparable to 5.0, and a few challenges were detected when doing the testing, that there is no differentiation between nodes having different processing power and memory amounts. So mixing low processing capability and low memory amount nodes will result in a tiny performance issue. But the solution for this was not implemented as a part of this feature. And then finally to the API changes. So in order to support different TX power levels, we implemented a new radio configuration API. This allows you to set custom power level tables and set up the FEM control if needed. To make utilization of the stack easier and to maintain backwards compatibility, each stack profile will contain a default power level table. So you do not need to set the power level table if you don't need to use that. So, and the default power level table should be enough for most use cases. And there's an application note about this radio configuration API, so the details aren't there. And then on the SDK side, we have the FEM driver or the FEM driver API, which is an optional component. So if there's no FEM on the platform, there's no need to implement such a driver. And then finally, to harmonize the RSSI value reported by the stack, it was changed from the, in my opinion, very confusing unsigned format to be in signed format and in dBm. And it is done for all APIs.
Thank you very much, Ville. Thank you, Ville. And let's talk now about the new OTAP mechanism. So floor is yours, Gwendal.
Thank you, Sebastian. Hello to all, and thanks for joining. In this first session, I will introduce the new OTAP feature we added in 5.1. But before introducing new changes, let's do a very short recap on what is over-the-air programming. So in a Wirepas network, thanks to OTAP, you can update the application, the stack, or any combination of multiple apps, a stack plus an app, or multiple apps. So this OTAP process happens in several distinct steps. So initially, you have to load a new scratchpad, so introduce the image to your network. And then the propagation is happening in the network, so node will exchange with each other the new scratchpad, and exchange is done by the stack in an optimized way, and it is stored alongside the running firmware in your node. One of the challenge, of course, in a mesh network is that all nodes must store the scratchpad even if they are not concerned by the firmware update. And then last step is the processing of the scratchpad. So you have to inform the node that they have to switch from the current running version to the new one, the one that is stored in the scratchpad. And all the authentication, decryption is done by the bootloader that we provide also. So it was a really short recap on what is OTAP. So now let's see what was the challenging in 5.0 and what we have done in 5.1. So let's start by the challenges that some of you have probably already faced. So loading of a scratchpad can happen from any node. What does it mean? It means that the exchange of the scratchpad can happen between any two nodes in the network without global synchronization. It means that, let's take an example, that you have a big network, but in different parts. So meaning that you have, for example, two buildings and they are not forming the same network, but later on you have a better density, and then those two buildings are linked together in the same network. Maybe the last OTAP round was not with the same sequence, and now you can have some scratchpad exchange that you don't really control. And also another example that happened several times. So you just visit one of your network with a node in your pocket, for example, with a different version, then they can start to exchange the scratchpad. So it was quite hard to control. Even if the scratchpad propagation is deterministic, errors are still possible, and mainly user errors. In fact, how two nodes are exchanging the scratchpad, it's only based on a sequence comparison in 5.0. And this comparison happen on a sequence that is only 1 byte, so only 256 different values possible. And it's not always straightforward for everybody to understand that, for example, the sequence 10 is considered as newer as 234, for example. So all these kind of comparison are not that straightforward. And if you wrongly choose your sequence when introducing a new scratchpad, it may lead to very, very bad things, and even create loop of exchange in your network. And last challenge from version 5.0 and before, of course, the scratchpad processing rely on bundling traffic. As we introduced in the previous slide, one of the steps of the OTAP is to inform the node that they have to process their store scratchpad, and it relies on bundling traffic. So of course, if you are not in the network when the message is sent, you cannot receive it. So it means that you have to send a downlink traffic message periodically to inform all the nodes to process, as long as you are sure that everybody has received at least one packet. So it is not that easy to implement. So let's move to the next slide to see what we have done to overcome all those issues. In this OTAP v2, we decided to have a very better control. So to summarize, we try to move from an implicit decision to explicit decision. So what does it mean in practice? We introduce a mechanism on top of the existing to have a fully controlled system by the sink. So the sink will always decide what the network has to do regarding the OTAP. So it can set a target in the network. And what is the target? It's what should node do with their scratchpad. So they can either do nothing, no OTAP. They have to propagate only their scratchpad. They have to propagate and process it, or propagate and process it with a delay. And to avoid any ambiguity, when we say, for example, propagate your scratchpad, we also add parameters to specify, okay, you have to exchange a scratchpad, but which scratchpad? So we associate with this target some parameters. The parameter is a sequence that you can freely choose, and also a CRC that is computed based on the scratchpad you have loaded. So this way, it's almost impossible to do a mistake, like we introduced in the previous slide. If you have a node joining a new network with a scratchpad store that has a different sequence as what is in the running network, now it will have to match the target to be exchanged with its neighbors. So the probability is almost impossible. So if a store scratchpad doesn't match what is set by the sink, nothing will happen. So no exchange, no processing, nothing. So one point to mention here is that most of the Wirepas network are multiple sink network. So all the sink in the same network should give the same information, because a node can be associated to any sink at any time. So to have something predictable, you need to synchronize your sync, so set the same target from every sync in the same network. And on the next slide, we can see that we also address the problem of reliability. So the information that we introduced just before with this target scratchpad is now propagated with a more reliable and persistent mechanism in the network. So if you have already developed application on top of Wirepas, you probably already know the, let's say, the app config that we offer for your application. Here we are using the same concept. So you set one time from the sync the target of the scratchpad and the target for the OTAP with the associated parameter, and this information will be sent to any node when it joins the network. So by just setting it one time from the sync, you ensure that every node joining the network will get it. So there is no overhead compared to multiple downlink message to, for example, process the scratchpad in previous version. You don't have any more to send them because just by joining the network, the new node will get the information. And it has also a very good consequence. It also means that even if a couple of days later a node arrives in your network, and I'm especially thinking of non-router long sleep, for example, that can sleep for a very long period, when they join the network, even if you are not sending any more update request, they will still get this information immediately when they join the network. So they can immediately take the new firmware and update themselves. So without any message from the backend. So this is the last point. It is that is another consequence. It works out of the box for advertiser and non-router long sleep. Before, in previous version, you had to do some modification in your application to support OTAP, but now it's all included on the stack side. And for this OTAP presentation, let's finish by a comparison of the flow that you have to do between 5.0 and 5.1. So on the left side, you can see the flow in a 5.0 network, and on the right side, a 5.1. In 5.0, as we said, it was quite tricky to find the correct sequence to introduce in the network to be sure that it will propagate right. You had to know exactly which sequence was stored in all the nodes from your network. So it is a step 1 and 2. In the new OTAP, you don't have to do it, because as you set the target at the same time you set the scratchpad. Even if, let's imagine, all the nodes are storing the scratchpad 3, if you introduce a scratchpad 2 with a different CRC, then it will propagate and process as you are expecting. There is no implicit comparison, so the node know exactly what they have to do. Of course, there is still one similar step, so you still have to upload the scratchpad to your sync. In 5.1, then you had to periodically send the request to the nodes and stop when you are sure that everybody has received it. So this is step 4 and 5 on the left side. It's not needed anymore in the new OTAP. Of course, you can still poll and ask for the status of the node if you just want to know when they all proceed, but it's optional. I mean, they will get the information anyway, so you can just, as in step 2, set the OTAP target to propagate and process your scratchpad, and you are done. You don't have anything to do. You don't have to resend the message, nothing to do. So that's why it was introduced by Seb at the beginning, that it is more reliable and faster. So you have less steps to do, and they are more explicit. And that is the end for this presentation.
Thank you very much, Gwendal. Let's move now to the radio installation quality by Ville. I just give a small reminder. Feel free to ask your question in the chat. We will answer at the end of the meeting. Floor is yours, Ville.
Thanks again. So radio installation quality. Again, what we will go through is a short introduction, then about methods on how to assess installation quality, present the new APIs, and finally a reminder about the documentation. So as we all know, Wirepas Massive is simple to install because each node implements automatic detection of its neighbors and automatic routing. However, problems can arise from the installation itself, more specifically a poor installation location. And this is defined as too few neighbors and the next top candidates, which results in poor redundancy and maybe even poor load balance. Then if you have only neighbors or next top candidates with poor RSSI, you have a poor link level quality. And obviously the big one is if you don't have a route to sync, and many others. And the problems can lead to either temporal or permanent connectivity issues for the node. And the radio installation quality API should make detecting such error situations easier. So it should be easy to find nodes that are poor location and perform cleanup actions if they are possible. They are not always possible, but at least this gives the option. And it should also be easier to analyze which kind of a problem the node actually has. And a bit more about that on the next slide. So how can you assess your installation quality? Well, the easiest way is obviously to monitor the received or missed packets and or delivered failed commands to the node. So uplink and downlink traffic. But this only works if the packets are sent periodically or there is some kind of identifier to detect received and missed packets. And as per the downlink commands, you need to have an ACK to know if they go through or not. Another option is to define installation rules, and obviously these are not mutually exclusive. Both can be done, but the installation rules, as per our definition, is that the node must have enough neighbors with good RSSI, and the amount of neighbors brings robustness and redundancy. So if a node is removed or a neighbor is removed, the node will still be able to send its data. And next, the neighbors should have good enough RSSI, because low RSSI with these radios means high bit error rate, and because there is no bit level correction in the baseband, it means high packet error rate. And this means that with good RSSI, you get fewer read transmissions and smaller energy consumption. And finally, you should only consider usable next top candidates because the routing direction matters. So the nodes that are usable for you need to be towards the sink with a smaller hop count. And then the new APIs. So we added a radio installation quality API, which contains a quality value. This value is calculated locally by the nodes themselves. The range is an unsigned integer with 8 bits, and this can be linearly scaled between 0 to 100%. And for good repetition, the value is calculated by the node itself, and the scoring of each neighbor is done by the node, and these scores are added together to form the final value. And the value can be indicated by any means, for example, on a display on the node, or by LEDs on the node, or by using BLE beaconing, which can be received by your mobile phone, or any other means. And the API also contains an error flag field, which suggests what the error is, why the quality value is so low, what kind of a problem does the node have. And the meaning of these values is presented in more detail in the application note, as well as the installation rules. They are also there. And as said, the installation quality value is available in all basically all Wirepas APIs, so single MCU, dual MCU, and the node diagnostics. And a reminder about the documentation. There is an application note about this, and obviously also the API documentation.
Thank you very much, Ville. A good tool to ease the installation. Let's move on to the MQTT library. So Gwendal, your turn again.
Thanks, Sebastian. So here is a presentation of what is a typical Wirepas network. So you may be already familiar with this, as you are already Wirepas partners. So on the left side, you have many nodes. You have 1 to n gateways, and you may have a broker behind and few backend application. So the backend application has to interact with the network. So most of the backend application have the same needs. So as a basic usage, you need to list your gateways and sync. You need to configure them. You have to receive data from your network that you can filter from any mean you want. And you want to send data to the network. And some backend can implement more advanced usage, like performing an OTAP in the network. So as these usage are quite typical, we decided to offer a library implemented in Python to simplify this network interaction. As everybody, all backends are doing all the same basic steps, it's better that we provide one version to ease your development and to simplify the initial integration. So this wheel is available from GitHub, and we generate also it on PyPy. So you have the link there. And what it means in practice is that it's a class that will wrap the usage of our API. So in order it to work, you need to support our API that we have defined that is based on MQTT and protobuf. So all the MQTT connection and topic is managed by the wheel, and the protobuf encoding decoding is also handled by the wheel, so you don't have to implement it yourself. To be totally frank, it is no rocket science, but it is designed to help and focus on basic needs. So there is no need to always reinvent the wheel and re-implement all the basic steps. So it should be beneficial for all of us. So if we take back the initial diagram, here is where the MQTT library is. So inside your backend, so it's totally optional. You can still use the API directly, but if you want to speed up your application development, you are free to use it. And of course, if you see something missing or any issue on it, feel free to tell us, and we will work on it for sure. And I will just show you a very short example on the next slide to show you what it looks like. So you can see that on the line 5, we just, if you are familiar with Python, we just import this class. We open what I introduced you, the Wirepas network interface class with some settings to connect to your broker, of course. And then you just have one call to register for data callback, and your callback will be called every time you receive a message from, in this case, anything happening from network 1, 2, 3, 4, 5 on endpoint 1, 2, 3. So quite simple example. So it means that you have an initial backend printing what happened in your network in less than 10 lines. I know that this example is very simplistic approach, but you can now just focus on handling your data. So this is where you have your added value. So this is clearly the objective of this wheel. And another more advanced example on the next slide that is linked to my first presentation. It also shows that in couple of lines you can implement the state machine we had on the right side, if you remember, in the OTAP version 2 presentation. So let's imagine you have a network 1, 2, 3, 4, 5 with a scratchpad to update. You just create again this Wirepas network interface. You have another wrapper on top of that for doing the OTAP. You select a sequence to update that can be random, because we still have this CRC and stuff to be sure it is completely deterministic. You load the scratchpad to all your things, and you set the target to propagate and process, and that's it. Just one point to mention here that I introduce you this CRC, and if you don't specify it, it will be automatically set to the scratchpad that was previously loaded from your sync, so you don't have to compute it yourself. So I hope you will enjoy this new wheel, and you will use it, and we are waiting for your questions and ideas to improve it if you have. Thanks a lot.
Thank you, Gwendal. That will clearly avoid to reinvent the wheel.
Exactly.
Let's move to the next topic. Antti will now talk about the other features and other updates that we need to highlight from this release. So Antti, your turn now.
Yes, hello all. I'm Antti Ropponen. I will talk about the rest of the new features. So as Seb earlier mentioned, we allow now to devices to operate without the 32 kilohertz clock crystal. So low latency devices do not need that clock crystal anymore. So low energy devices still needed because of the higher demand for accurate clock to preserve power. Well, this basically enables savings in bill of material, but it also opens like wider support for existing devices. Like, for example, there is a lot of LED drivers on the market that has compatible radio, Wirepas compatible radio, but doesn't have the clock crystal. So now all of them are available to be used with Wirepas. Then we have the support of the 2 more Scilabs chips, SoCs, so G21 and G22. As was mentioned earlier, G21 is supported with full feature set of Wirepas Massive, so it can be used in all of our applications. And the G22 is kind of a new step because it's limited for it's limited to non-router usage and in low energy usage. So it's basically because of the limited memory resources. It doesn't have enough memory to do routing. But we decided to enable it because it's very well suited with low-cost tags in asset tracking applications. Also, like light switches could be one application to use this chip. So it's a like a new low-cost, low-energy SoC to be used in this kind of low-power applications. Then there's a change in sync broadcast. So we have adaptive flooding, which means non-acknowledged broadcasts in the network. So when it's sent from a sink, it spreads to the whole network. Previously, it was limited in the sinks network tree, but now it spreads to the whole network. So if there is messages initiated from the gateway, it spreads to the whole network. So it has the same functionality as any like node-to-node messages that are initiated from another node. So it's about harmonizing the features, and the feature works only in the low latency devices. So there is no possibility to send adaptive flooding between low energy devices. And some deprecated features which will be deprecated in the next release. They are still available, but we have a basically strong suggestion to remove if they are used. So there was an old remote beacon API, and it will be deprecated. But the beacon RX and beacon TX libraries will remain in the single MCU SDK. So most of you, I think most of you are using the beacon RX and beacon TX libraries, so they will remain. Just the old API will be deprecated. Then also the local multicast, which is basically a slight improvement to hop limit, to like have a more clever hop limiting. So there is no real use for it at this point, so it will also be removed in the next release. Thank you.
Thank you, Antti. Let's move to the next part. So how to migrate to 5.1, and Kari will give you more information about that.
Yeah, thanks, Sepp. My name is Kari Pihl, and this topic is a high-level migration items, how to get to the 5.1 from the earlier releases you have operating in your network. So first topic is that if you are planning to use any of the 5.1 new features, then you would need to actually go and update this network to the 5.1 as a complete. So we are not recommending to operate this kind of hybrid networks, even though there could be some possibilities for that. So it's easier to maintain if you look either 5.0 or 5.1 complete network. If you are operating 4.0 or 5.0 network at the moment, there are few remarks to be made. So if you are now having a 4.0 network, so what we introduced between a 4.0 and a 5.0, there was this radio level incompatibility. So once you update from 4.0, so that is possible to be updated to 5.1, but you need to look it as a complete network update at the once. And also the recommendation is that once you do this update, you would also targeting to update the stack and the application on the same time. And of course, the application is also recommended to be compiled with the latest SDK. So when you update from 5.0 to 5.1, that is a bit, let's say, more straightforward, because there is this radio compatibility. But here we also recommend that you update the 5.1 stack, the application at the same time. And certainly there are, of course, some positioning network update needs, and that would need a bit more special care, and we are having more details on that on our application note on the migration. When we look about the different parts of the things, so on our 5.1 release, so bootloader, so you don't need to update the bootloader when you take the 5. Stack into use. So you can use 4.0, 5.0 bootloader if you are not planning to have any, let's say, for any reason, the updates. There are, of course, some features in 5.1 that would require the 5.1 bootloader. For example, if you're planning to take this operation without 32 kilohertz clock in use, then you would need to have the 5.1 bootloader. And if you plan to update the bootloader, so our customer support team is helping you on the details how to do it and giving you the tools for that. On the SDK, so the existing application you have created on 4.0, 5.0 works, but we recommend that you would be using the latest SDK to compile when you update. For example, from 5.0 to 5.1, you would update the stack and the application same time, and the application would be built on the latest SDK. On the gateway side, so maybe Gwendal already mentioned that that you could use your current gateway gateway driver with 5.1, but if you plan to take this new OTAP control into use, then you would need to migrate your gateway also to 1.4. So we will provide you the more details about this migration on this documentation, and that will be provided along the release. So I think this is in a nutshell few topics about the migration. Thank you.
Thank you very much, Gary. Let's move very quickly to some practicalities, and then we can move on. Sorry, to the Q&A session. We have received quite many questions, so we will most probably go a bit over time. Try to answer as many as possible, but we will answer the most important one first. Where and when to find the 5.1 and the associated components. So the stack and the documentation will be available later today. So you will get access on the respectively share file, GitHub, and the developer portal to the stack, the open source component, and the documentation. The Wirepas gateway and the MQTT library are already available on GitHub, so feel free to look at them now. And the network tool, as said before, will be released next week. So you need to wait a bit for that, but that will come next week. And please make sure that when you enter a support request related to 5.1, you select this version in your tickets. That will help the support team to properly answer to your question. On the right side, a quick recap about what is available where. So the documentation, the VNT client, the VNT backend installer script, and the terminal are now all available and will be available from now on the developer portal. GitHub remains the place to get all the open source components, so the SDK, the dual MCU API, where the documentation will be also on GitHub. New updates, as well as the gateway drivers. And the share file is mainly to exchange the stack and the VNT self-hosting key and VP library. So really the component under license. We are now at the end of the presentation, so let's take time to take a couple of questions. We have received many, so let's try to answer some of them now. There was one very easy question, which is can I get access to this presentation as well as to the replay of the webinar? And the answer is, of course, yes. So you will get access to that from the developer portal. Second question, maybe this one is for you, Carrie. Is the FEM tool available now?
Yeah, thanks. So, so good question. So this FEM support is actually provided through our SDK. So there is of course this application note that explains about how you would be able to take this external FEM devices into use and what you would need to do. But on the SDK, that actually the tool that enables you to take this feature into use.
Thank you, Kari. Next question. Can mixed 5.0, 5.1 network be updated only with legacy OTAP, or do 5.1 nodes need to be updated with OTAP v2? Gwendal, maybe you want to answer this question?
Yes, sure. I should have mentioned it in the presentation, but yes, we implemented on a backward compatible side. So 5.1 nodes will also support the legacy mode, and one of the target action for the network is to operate in legacy mode. So as long as you have 5.0 node in your network, you have to use this legacy mode. But we highly recommend that all your nodes are running 5.1 to only use the new OTAP to benefit from all the new aspects.
Thank you, Gwendal. And the side comment on that, so we have released numbers of new documents. There is now an OTAP application note which describes more in details about how the OTAP works. And we have released how to make an OTAP with 5.0 and 5.1, which will be released later today. You will find inside those documents all this information regarding the backward compatibility and the different combination of different version of nodes inside the networks. I'll continue with the OTAP while you are here, Gwendal. Now OTAP propagation takes priority over normal network communication, resulting in temporary but significant impact on the network. Is it something done or planned to address this feature? Maybe I can reply, and Gwendal, you can support if there is any additional comment. This is a very good question, and as you may have understood, the OTAP works in terms of the propagation the same way as it has always been implemented. This OTAP v2 is about better control and more explicit configuration, but we don't change the propagation. So indeed, when we transfer a scratchpad, there is an impact on network because there is exchange of the scratchpad. This is something we are thinking about, for which we don't have any committed plan as of today. The objective was really to make it more easy to use and more reliable. And also there are numbers of pro and cons, I would say, by one choice or the other. So there is no commitment that we will introduce a new way to do the OTAP in an upcoming release. Okay, another question on the OTAP. Is scratchpad propagation using broadcast? Is there a way to propagate it to selected nodes only? Maybe Gwendal, you want to answer this question?
Yes, and answer is exactly the same as what you have done just before. So scratchpad propagation is independent of the data path. So any unicast or broadcast, it has its own way of propagating that is that doesn't support the selected node.
Thank you, Gwendal. Another very interesting question. Maybe Yoni, you can answer this one. How to ensure that nodes from multiple vendors can run in the very same Wirepas Massive networks? This question is regarding possible colliding IDs like endpoints, OTAP, app ID, and different app config format. is there a central register at Wirepas? Joni, do you want to answer this question or shall I answer?
Sorry, I was double muted. I hope
Thank
you hear
you.
me now. So,
Yes.
like you already commented, I do second what you said. This is a very valid question. As the networks grow, there's more interoperability, and this endpoint management becomes a more valid topic. We are considering this, and it's something that we want to put more effort in the future. But at the moment, we do not have this central repository, and of course, if there are such cases, let's work together with our customers on how to handle those. But something that we are keeping our eye on and looking how to improve in the future. At the moment, we do not have a solution to it.
Thank you, Joni. Next question. Is VNT 3.x compatible with Wirepas Massive version 5.1? I can answer this one. The answer is no. There is a backward compatibility on VNT4 supporting the previous version, but because of the introduction of the OTAP v2 and because also of some updates on the boot diagnostic, the VNT 3.x is not compatible with Wirepas Massive 5.1. This being said, of course, we will provide scripts to update existing backend based on 3.x to 4.x. Let's take maybe a couple of additional questions. So a question regarding the local multicast. Why is the local multicast feature exactly going to be deprecated? We see potential use for swarm lighting use case. Maybe Antti, you want to take the question?
Yeah, so it wasn't used at all, and at my knowledge by any customers, and normal hop limit seems to be enough at this point. We saw it may arise different problems if for example, nodes, some messages are received from a group, from a member that doesn't belong to different groups, so it might raise other problems. So basically it was decided to not support that at this point, and maybe if there is a need we might come back to this, but at this point we don't see any usage, and hop limit is just enough as a feature.
Thank you, Antti. And then we have a couple of remaining questions. Does OTAP v2/MQTT library has provision to monitor the progress of OTAP automatically? Gwendal, maybe you want to answer this question?
Yeah, I can. The answer is yes and no. I mean, we have seen with this MQTT library that it implements all the basic operation on the network. So receiving data and sending data. So if you want to know, for example, if the scratch pad are received in a node, you have to ask its status to the node. So you have the needed block to send data and also to receive the data. So on some extent, yes, it's supported, but not out of the box. We have examples that are doing more or less that, but depending on your need, you may have to adapt it a bit.
Thank you, Gwendal. And there are still questions on the OTAP that generates a lot of interest. Can we use the old OTAP mechanism with devices running the version 5.1, or do we need to use directly the new OTAP? So this question has been partially answered, but I will explicitly answer to this one. Yes, it is possible. For example, in case you already have developed your own backend that is using the legacy OTAP, the current OTAP of the 5.0 in your system, or if you are not having up-to-date gateways or gateway drivers, you can still use the legacy mode, which works perfectly. Of course, you won't get the benefit of the OTAP v2, but more or less it works the same way. It's just about better control and something more reliable. So yes, this is supported. There was another question regarding do we have updated version of OTAP reference manual for 5.1? I would say yes and no, mainly because we have slightly improved the documentation on the OTAP. So there are now different documents which will help you to understand this in a much more detailed level as the current documentation. We have application note, we have how to, we have also documents which describes how the memory map is made on the system. So you will see numbers of new documents that will, in my opinion, slightly improve the access to and the understanding of that. I'll just take two additional questions and then we will close. What are possible reasons behind needing to OTAP to update, the bootloader? Maybe Kari, you want to answer this one?
Yeah, there's also in the release notes highlighted two topics that were linked to the 5.1 features or some improvements. So first one was this: if you target to have this 32 kilohertz crystal-less operation, so then you would need to have a bootloader from 5.1 to support this feature. The other one is that we have done some improvements of using the external flash for OTAP. So that this is also the reason to update. So there is no other features that we have brought on 5.1 that would let's say force you to take the 5.1 bootloader. So if you are not using this or planning to take to use or updating existing networks, you don't need to update the bootloader, only the stack and the application.
Thank you, Kari. I'll just take the last question because it's also quite interesting one. Can we OTAP from 3.x directly to 5.1? So this is a bit linked to what Kari said. Unfortunately, between the version 3 and the version 4, there have been here a bootloader change. So there is a need to update the bootloader. So it's, I would say, a little bit less straightforward. I just take the opportunity of this question to highlight again that we have at beginning of this year announced end of support notification for the Wirepas Mesh version 3.x. And if you are in this transition, I would strongly recommend that there is a direct interaction between you and our customer success team in order to define together with you the best strategy and the best plan to manage this transition from 3.x to 5.1. So feel free to log a ticket on that or ping your account manager. We are here to help you on those transitions. We are roughly 10 minutes late, so I think it's now time to close this webinar. So I'd like to first of all thanks all participants to the webinar. Thanks for taking the time to listen to this new release, and hope you will enjoy the new features and the improvement we have made on this 5.1. Of course, your account manager and the customer success team remains available for any question you may have. There are a couple of questions that we have not managed to answer today, so we will come back to the requester offline with answer to those questions. Thanks also to the Wirepas team with me today for this webinar. And you will get access to the replay and the slides later on. Thank you very much for your attendance and talk to you soon. Bye-bye.